Hey everyone, so today I'm going to go through a video on plotting in R. So basically, since we've gone through how to manipulate data and try to clean it up clean it up essentially, now let's try to see if we can create some plots or visualizations in R. So probably first thing is just to kind of go over base R and ggplot. And so early on, you might be wondering, like, there's two different forms of plotting. Which one should you use? Which one's better? I feel like either one is fine, but you'll find from other people that they have very strong opinions on it. For example, this is like a famous post that basically they hate ggplot, or the package is called ggplot2, but it's just commonly referred to as ggplot. But yeah, so people usually some people have strong opinions. His take is that he likes base R because it's easier to create exploratory graphs. He finds easier to make figure quality graphs too, and it's helpful when he's just trying to look at student. It's easier to grade student data analyses using it too. So as one point of view, I don't think this is the most common. I fall more into this camp. If I picture down with this like Calvin and Hobbes cartoon, where basically I find making stuff in base R to be a lot more work. So yeah, this is kind of like a rebuttal to it, where David Robinson makes a point you can do virtually all of what you can do in base R and ggplot with much less time. So feel free to check out these links to read what they say. But what I really want to drive home is that I think either one of them is totally fine. Whichever you find easier, just go with that, or whatever you prefer. For the vast majority thinks it's easy to do them both ways. I'll show you some, especially at the end, where I think it's actually much easier to do stuff in ggplot when it gets a little more complicated. But especially for exploratory figures, I think base R can do it just fine. And you'll find with a lot of the modeling, like when you're doing linear modeling, running stats, that a lot of the assumptions you test, there's built-in stuff from base R. And so if you're just creating those plots, there's no reason to recreate them in ggplot. The nice thing about R is that the R community is very accepting, and it's more of, if you can get the right answer, that's great, as opposed to being some purists on which package to use. So use whatever. I prefer ggplot, but they're both great. Okay, so for this video, I'm just going to first run through some of the fundamentals of base R, and then I'll jump over to R and we'll go over some examples. Then I'll do the same thing for ggplot. And at the very end, I'll create some figures using both of ggplot and base R. And all the examples will use some toy data sets, or mostly just me randomly generating numbers. So the first thing I wanted to talk about before we dive into base R is that one thing that makes it kind of challenging is that there's kind of two different ways you can write out a lot of the base R functions. And so there's two main syntaxes that are used. One's called the $sign syntax, using the left, or also the formula syntax. And each of these will give you the same exact thing, it's just a different style. So for the $sign syntax, or for both of these, imagine you have some data frame that's called data, and you're trying to plot the X and Y columns as your X and Y variables. And so if you're just trying to, see my cursor, let's see it. Oops, that one. Laser pointer. Hopefully this comes up on your screen. So if you're trying to plot, just say the X and Y variables using the $sign syntax, you first write the data frame you're using, and then $sign allows you to pull out that specific column. So this is creating a vector from this, and this is creating another vector from the Y column. And so if you go down here, you can see if you wanted to create, say, a scatter plot with two continuous variables, you can use, really switch to different packet or different data frames. So empty cars, and your X is your display column, and then your Y variable is the empty cars MPG column. And so that's one quick way. It's written in X and then Y, and you're separated by a comma. So that's, I think, very intuitive when you're first starting, because it's just plug X and Y in. But you'll often also see what's called the formula syntax. And typically this is more common because you'll see it when you're building linear models, because this is how you have to write them for linear models. But you can also use this for doing any plots as well. And so it's kind of, you're flipping the order. So now it's Y tilde X, and the tilde just stands for distributed by. So this is going to be whatever your response variable is Y, and then X is going to be your predictors that you're plugging in the linear model, but also it's your X values and the plots. So if you go down here, they're using examples with lattice for these, but you can use this kind of still the $ or BW plot. Imagine that's just plot. It would work the same way here as this one, but that will give you the same exact thing. And then, as I talked about last time, there's also here the tidyverse syntax, and we'll talk a little bit about its kind of within that family ggplot. And so we'll kind of get back into that for a bit, but for now we'll skip that. Okay. So now just know here are the two different syntaxes, and then here are the different functions. So in base R, to create these different plots, they're all kind of the separate functions. So to create a histogram, you write HIST, so short for histogram, and then you give it some vector. So in this case, I just put X, but imagine it could also be like, if you have a data frame named data, it could be data frame, or sorry, data, and then the $ X as well. And then down below, here's like a scatter plot. So do a scatter plot, all you have to do is use the function plot, and that'll create that scatter plot. And I forgot the comma here, but there should be a comma in between this. And this would be like the normal $ form versus this is the formula form. So you plug your X and Y, and then it'll create dots for everything. If you want to create a box plot, I just show the formula in here. It's just kind of the same thing, but now you switch in the word box plot, and then it'll summarize it based off the categories of X you give it. So in this case, this is continuous, this is categorical, and it'll summarize it at each of those. In this example, month. To create bar plots, it's a little tricky in R, but essentially to create a bar plot, you're supplying the counts, and then you have to supply the counts and then the names of the different bars. And so you can either plug in a table to do that using just bar plot, and then this X that's a table form, or you can just supply a vector that counts and then name the names of the bars here like this with using the vector. I'll give an example of this in the Power or in the R scripts. And then, so once you do that, you kind of get your, if you're using any of those other functions, they just kind of create the raw plot. If you wanted to clean it up and kind of make it more readable or add more information, you can do this by, say, like adding a title using the main argument. So main equals and name your title. Then you can label your X and Y axes with XLab and YLab. And then say if you want to set kind of the limits of the X and Y axis, XLim and YLim will do that. And you plug the low number and the high number for each of those. And then you're also given a bunch of extra, oops, sorry. Let me take off the laser pointer, will let me click the screen. Besides that, you can change a lot of the other things too. And here's a bunch of the other arguments. So if you want to change the width of your line, so say you have like a line plot, you can do that by putting a different number. So I think one's the default, but if you put 2, 3, or 4, make it thicker. And then you might be wondering, I didn't explain how you make a line plot. The way you do that is you take the normal plot function, and then you add the type equals this L here. So these are all characters. And so this will change. So the default is to give you points when you have two categorical variables, but you can switch it to be a line like that. And then you can also do both for those. You can also change what kind of line, solid line versus like a dotted or a dashed line. If you want to change the size of the points, you can use that with the CEX command or argument. To change the color, you can use call, and then either type in the RGB code, or you can even type in just as a character, just green, and I'll do that. Do you want to change the shape? Use the PCH, which is not the most easily rememberable one. And then these are all ordered. And so if you do, so this is like 1 for the circle, 2 for triangle. And so I believe 16 here is a solid dot, and I'll use that later. So these are kind of like the ways you can modify just a simple graph. And so it actually is relatively quick to make a plot using this form. So it can be really helpful. So let's jump over to R now and start seeing what we can do. Okay. Let me check, make sure my screen's sharing correctly. Sorry. Okay, cool. We should be in my screen now. Sweet. I think it might have worked before, but cool. So now I'm just going to go through some of the code for it. So I'm going to use a lot of random functions. So one thing you'll see often in Tapas scripts is they'll use this thing called set.c. And so in R and like a lot of programming languages, pretty certain all of them, there's no actual random numbers in these languages. Instead, they're working off some kind of set seed where it's just kind of, they're just kind of written out. And so if you set this one seed, it actually will allow, if I use some kind of random function, for you to get the exact same numbers out of it. So it's a way to make it more reproducible and hopefully give you the same things that I'm getting. I'm going to clear everything, and just as like good practice, just show you like, here's how you restart R, clear everything in here, make sure there's nothing in my environment. So we're good to go starting now. Okay, so then I'm going to load tidyverse because I'm going to use that to clean up some of my data. So just load tidyverse is going to tell me the packages it's loading, the conflicts, all of it looks good. It tells you the versions. And so now let's get into plotting in R. So let's first create a data set called toy, and we'll use this to kind of see how you can easily make a plot in base R. So I'm going to create a data frame with this, and it has 2 columns, A, which goes from 1 through 6, and then B, and it's this, all these, a vector of all these numbers. So we can look at toy. So you can see here's A, here's B. So we can use this as X for A and then B for Y. So it's just a few numbers to plug in, make it easy to work with. So first, let's just show you how easy it is to plot. You just run plot to create a scatter plot. And then you'll see in the bottom right, it's going to switch over to the scatter plot. And I'll switch to that tab here. So now we have our quick scatter plot. I can show you quickly how the formula version would work. So it'd be B given or distributed by A, and then we'll have to plug in the data, which is just toy. We'll say the same thing. And since actually I'm giving the formula form, actually it's not right, it's A and B, as opposed to the $sign forms, but not a huge difference. But we'll just stick to the $sign syntax for now. So to add the title, we're using the main argument and supply that. And so it makes the title quickly. Next, let's add the X label here. So you can just keep stringing on all these other arguments. So I changed the X label here. We'll change the Y label here using ylab and just name it Y label goes here. To make it easier for other stuff, I'm going to put all the different arguments on their own line from here on out, just so you can see all of them stacked. So call changes the color. We're going to all set them all to blue. You can see it changes the outside blue. Of course, you can make it anything. You can make it green, make it purple. There's if you Google it, usually you can find these huge tables and tells you all the different character or different names of colors that it'll accept. So we'll stick with blue. Then next we'll do PCH to change the shape of the points, make them solid. Be solid blue. Next, we'll change the dimensions of the x-axis. So when you create a plot, it's going to just scale it to what you've entered. So we have 1 through 6 as our x values, but I'm going to change it to be 0 to 10 and just kind of zoom out a bit. And so you can see now it got pushed back a bit. And you have more room over here for 7 through 10. And then we can use the type argument to make it into a line. And so now it gets rid of the points because we made it into a line. Of course, you can change it to get both the points and the line if you go back to that table. And so just showing you there, we built up from like a really simple plot to add all these kind of features here to clean it up a fair amount. So one thing you'll see, no matter if it is base R or ggplot, you'll see that like the actual code to make just the bare minimum of what you need is like only like a 1 line, but then to clean it up and make it more presentable is going to be like 80 to 90% of the code. And that's okay. So let's say like you wanted to add data from like another data frame on top of this line. And so what you can do in base R is you can just keep overlaying data on top of this plot. And so we're going to create this other data frame called red line. And this data set is just I'm going to generate random numbers with it. And the way I create random numbers is using R uniform, which just is random uniform. So it's pulling any number. So I'm going to pull n. N means how many we're creating. So we're going to create 6. The minimum value would be 0. It's going to be between 0 and the max is 10. So between 0 and 10. And we'll do the same thing for B. And so this will create random numbers for us, which are nice. So here's what they look like. And so it's nice, just fun values you can plug in. And since we're going to use line, it makes it easier if you sort the x value so it doesn't create more like a connect the dots-esque kind of figure. We want it just kind of ordered. And so I'm just going to do this quickly using the sort command to rewrite the A vector within data frame. So this will switch the order, but since I'm just simulating data, it doesn't really matter. If you wanted to retain the order of the rows, then you'd want to do a different approach. And like we talked about last time with using arrange and tidyverse. But this works for now. And so since we already created this plot before, now we can add the lines on top of it really easily by just using the command lines. And then just your X and Y using $ syntax. Call equals red to make it a red color. And you'll see there's our new line that's red on top. If you wanted to add points as opposed to a line, this is just going to overlay it, but the points command will allow you to create the points too. So that's how you kind of overlay data. The next thing I want to run through is more like what if you wanted to plot a regression on top of your scatter plot. So let's first just create data that will be useful for a regression. So we're going to create values of A that's between 1 and 100. That's what A looks like. And then we'll plug in those A values into the mean of the R norm function. So R norm, it's just pulling random values from a normal curve. And since we're setting the mean to the index we're using, it's going to actually fit a nice linear relationship. And the standard deviation is going to create some of that noise around it, depending on what value you put in for standard deviation. And so I can show you, but it's actually kind of cool to play with it and see how tight it fits the line versus how noisy it gets when you increase the standard deviation. But anyway, so then we'll create a vector B. And then finally, I'm going to create some kind of categorical variable. I'm calling it size. I'm using the sample function, which takes in a vector. And then you say how many, it's imagine just like your classic from probability classes where you have like a bag of marbles and they're all different colors. It's the same idea. And so I'm just going to randomly draw 100 of those and then replace equals true. So it'll allow me to grab, say, like small again and again. So we'll grab this vector, create this vector called size. And you'll see it'd be like called just be small, large, and medium, repeated a bunch. And so using all of this fun random data, we can compile it all into one data frame here. And one important thing is I'm going to set size to be a factor because that'll be helpful later when we're using size to change the color of the data points. And so now we have a new data frame, A and B, kind of like we were doing before, and now size as well, matched up. So first we can just plot the X and Y, kind of like we did before. And you can see here, right, that it fits. You can see it'll fit a linear relationship really well. Like if I set this to 5, and then we reran this, we have to recreate the data frame again. You see the fit will be much better versus like if I put 50 in, it's going to be much, or it's going to, you'll see it's much noisier. Yeah, it's harder to see a relationship there. But we'll go back to 10. And since I reran size there, as you notice, they'll actually regenerate the random draws. So here's our data frame we're going to be plotting. The values are different for B and size than the first time I showed you this, but it won't change too much. So here's kind of what the data looks like for A and B, or X and Y. And so first, to create the linear regression, to plot that on top of it, we have to compute the best fit linear model for it. So use the LM function. Oops, I accidentally, yeah. Here's the actual code where they run to calculate it. If you can open any function, but LM is how you run fit a linear model. And so first you just plug in the formula, and then we just need the data we're using. So do this, we'll save it as the linear model. And so linear model creates a, linear model will create a, I want to say list, or it's LM function. It's a list form. Yeah. List of 12. And so within that, you can kind of pull out the coefficients using the coef function. I'll give you the intercept. Will give you two different lists, the intercept and A, which is just going to be your slope. And so you can see, right, since I plugged in our index with it and just pulled it from a normal curve around that as the mean, the slope should be very close to 1 just by design. So we created our linear model, which is great. And then the easy thing to do is all you have to do to plot it is use this function called abline or AB line, and then that will just plot it with the coefficients you determine by fitting that linear model. So just put in the model name, and then you see it creates a line. And you see it should fit very well because this is data that should fit a linear model. And so that's how you just easily create a linear regression on top of it, Quasar. Now, one thing you can do, and you can plug in, say, the call and give, say, that size factor that we threw in or created earlier. And so if you give it a variable like this, or you give it a factor specifically, you can actually then change the colors based on that factor. And then PCH 20 is just making it filled in. And so that can be really helpful. Here's the same thing just in the formula form. So it can actually make it much cleaner because you don't have to write out the $ notation for everything. And then here I'm just going to add the regression again. And then you can change the color of the regression and like the width of the line. So make it now a much thicker line. So easy way to get some data, and you can kind of see what it looks like pretty easy. Last kind of thing on this we'll talk about is just adding a legend. So first thing for a legend, you say kind of where you want to put it. You can actually specify like the pixels and everything, but it's easy just to write like top left or bottom right or etc. And that'll put it there. And set just tells you you're pushing it in a bit. Title of the legend, we're just going to call it size because that's what the factor we're working with. And then, so sorry, I'm just making a legend for the different colors for this plot for the dots. And then legend equals, this is where you plug in the name or the different levels of that factor. So I'm just going to write levels of the linear model size like that. Call specifies the colors, so it's 1 through 3, so match up with the call here. And PCH equals 20. To run this, it'll create the legend that will correspond to it. And it'll just keep overlaying, but I can show you, or if you write bottom right, it'll put it in the bottom right corner. Of course, I would have to recreate the plot to get rid of that first legend, so we'll have double legend for now. That's okay. But if we just ran all this again, recreate the plot, then it would just be that plot there. So that's kind of my overview of scatter plots and lines. Next, I'll kind of give you some box plot examples because those are helpful too to create. So I'm just going to create more random numbers or following from normal distributions. So I'm a sample of 30 mean of differing means and standard deviations. And so this creates this box plot DF, and then you see each of these are, say, are different groups A, B, C, and D. So if you watch the other video, recognize that this would be considered wide form. And you can actually, for box plot, just plot it in wide form. And it'll just create a different box for each of the columns. So that works totally fine. However, the vast majority of stuff you'll do, you'll need it in long form. So here's some quick code to pivot it to make it long form. So here's what the long form would look like. So we have our groups column, and then vals is our values. And so from this, you can use the same kind of formula notation as before. And then that will create the same exact figures we had in the other one. So easy to make box plots like that. It'll kind of summarize each of the boxes for you. So that's super nice. Kind of the last few things with base R I want to touch on is putting multiple graphs on the same page or same screen. So if you keep running plot right, it'll just cycle through different plots. So you can actually go and hit this arrow and see like all the stuff we've created in the past. Let's say you wanted two kind of box plots next to each other on the same figure. What you have to do that is you have to actually change the options for the plots kind of panel here. And so you do that by using this function called par. And par pulls up kind of the graphical parameters for this window. And then within par, there is an argument called mfrow. And this tells you kind of how many different plots you want to put on that one screen. And then so the first element in the vector you supply it is the number of rows, and the second is the number of columns. So this is saying that I want one row, but I want two columns of like two plots next to each other, side by side. If you wanted to do two plots like on top of each other, you would do 2, 1 for that. But first we just run this. First, you won't see anything at first and might not seem like it's working, but you'll notice really quickly once we put in one of the plots. So let's recreate the toy plot. And you'll see when I run this, it'll take up only half the screen because we're saving the other half of the second plot we'll run. So now when I run box plot, it's not going to clear out that first plot. It's going to actually put it next to it. And one thing you'll notice is sometimes with the screen, the words will be cut off, but it's really easy if you can also open it and see it rescaled. Oops. And you can see that all of it fits on there. So this is an easy way to get two plots on the same screen. And then so you can save this for publication. So the save data, that's what we'll talk about next. And so what we'll do for that is one thing you can do is like you can just, if you want, you can just export this directly using this function here. And then you can change the width and height, change the directory, change the image format. Sometimes it's easy if you're just kind of trying to create quick figures. But if you want code that's reproducible, you can also write in your script to do that automatically. It's a little complicated with Basear, but here's kind of the approach you do. So first before you run your plots, first you set up the path to where you're going to save the file. So I'm going to create a PNG image. We're going to name it toyplots.png. The height of it's going to be 6. The width is 10. The units for the height and width are going to be in inches. And then I'm going to specify the resolution to be 300. So first you'll run this. You won't see anything, but it's just kind of priming you to create the figure. And then let's just set the par again. If you rerun par, it should clear the panels when you adding another data set. So first we'll plot this. You'll see nothing actually changed. And then we can do box plot as well. And then when you run dev.auth, this will actually then write it to that toy_plots.png file. And so if we go over to, I should pull up on my files. You should see that, yeah, this just got created. Here's our toy plots image. So here's the thing we just created. You can see the image is just as it should. Looks great. Sweet, made our first figure. Okay, and then if you ever want to go back to show only shows one plot at a time, you use the par and set the MF row to 1 and 1. So 1 row and 1 column, and that's it. So that's kind of what my intro for going through Basear. Now let's kind of dive into ggplot. Back to PowerPoint. Okay. So you might have heard ggplot before. It's one of the more common packages in R. And it's this really cool package that makes it much easier to plot data and to do kind of complex things really quickly. And so that it was created by Hadley Wickham. This is actually abstract from the paper. It lays it out. And it's built off this idea of grammar of graphics. And I won't read you kind of this paragraph, but it's easily summarized from the cheat sheet, like here. Move my screen down. So ggplot2 is based off the grammar graphics, the idea that you can build every graph from a few components. So a data set, a set of geoms, visual marks that represent data points and coordinate system. And so it's kind of similar to the philosophy of tidyverse. In fact, ggplot is a member of the tidyverse. It actually kind of predates the rest of tidyverse, but it's all kind of created by Hadley Wickham, so it's all very similar. And so what you do with it basically is you have your data, and then you basically create this kind of foundation for it, which is kind of in the AES aesthetics within the ggplot. And then you're kind of just layering on ways of interpreting that data. And so first, when you create that first ggplot object, it creates kind of the contours of what you can do. So it sets like your x-axis and your y-axis. But then on that, you add your geoms. So that's like the coordinate system. Then you add your geoms on top of that to create the points and lines, or how you can modify kind of the aesthetics of those. So basically, no matter what you're doing when you're plotting, you're kind of choosing your x and y variables and maybe some other kind of mapping like color, etc. And then you're just layering stuff on and modifying it. And so you're using the same process for all of it, but say you might be doing a box plot for one, or might be doing a line graph for the other. And so it's the similar idea to tidyverse, right? Where it's universal, but composable as well. So I have all these little pieces that build up to build something really complex. And so just to kind of show you the kind of theory of it. So this is how you'd run ggplot. First, you call the ggplot object. Then you supply your data frame with the data equals parameter. If you watch the other videos, you might be aware of piping. And so you can actually pipe in the data in here and skip that data argument. That's kind of what I'll do in a second. And then you'll have your AEX function. This is kind of like if you use like a metaphor of a house, this is kind of setting up the foundation. So you're saying what you're going to use for your X variable for every GM, which is kind of what you're plotting. So everything beyond this we'll use this X, and every Y, all of your Y axis and Y variables will use whatever you plug in for Y here. And then geoms are referring to what we're going to draw using those aesthetics. So if you do gm underscore line, it'll create a line graph. If you do gm underscore point, it'll create points, and etc. There's a bunch of geoms. I'll show you all of them in a second. But whatever you put in that first aesthetics is what's going to be used throughout those other geoms, unless you specify later you want different data. And so here's more information on it. So here's the data you plug in, ggplot, AES, and then so this is our X variable highway, and CTY is our Y variable. And so we're going to say, this is so you create your foundation. And then when you want to add stuff and build upon that foundation, you do it by adding a plus sign in between. And so it's a little different than doing dplyr, right? Because dplyr is connected by using the pipes. So it's kind of directional. I guess think instead of the kind of like very directing, yeah, I guess directional nature of dplyr. This is kind of you're building up and stacking stuff on top of each other or modifying it. So we use plus sign, and then so this is going to say to make this into a scatter plot by using gm point, AES, and then color equals cycle. And this is kind of doing exactly like what we did in the base R example. So it's going to take the SYL column and create different colors for each of them of that factor. And then gm smooth, which will actually add the regression line method equals LM, so linear model. But then you can add all this other stuff too. I mean, like you can then say add coordinates like Cartesian. And then later down, you'll see that there's things called scale. So scale is kind of taking your aesthetics and you're kind of tweaking or modifying them. So this is like you can change the different colors you're using. This is like where you would plug in like to change like the limits, etc. And then theme underscore BW kind of creates just a different style to the plot. And the general ggplot style is kind of not great. So I usually add theme underscore BW to my plots. There's more stuff too. You can add stat functions as well. I'm not going to go into those because I don't really use those much at all, but there's a lot more you can do as well. And to show, here's just to show you the diversity of GMs you can draw onto those aesthetics. So if you have one variable, you can do areas, you can do density curves. This is where your kind of histograms would exist. But then you can also say like if you have X and Y are continuous, you can create your scatter plots, you can create quantiles, etc. You can add text. You can there's a bunch of stuff on here, and you can draw almost like any graph you can think of using these. And then these are all organized by what type of data, if it's continuous or categorical or discrete, as they say here. So yeah, lots of options. One of the powerful things, and it'll be very clear with the water example at the end, one of the powerful things about ggplot is this idea of faceting. So faceting allows you to break up your big graph by some kind of category into kind of smaller graphs within it. And so imagine you had this ggplot where it's, here's the data, so MPG, and you have CTY, which doesn't make me anything, but imagine this is just like a scatter plot. And you have some other factor named FL. And with this factor FL, you can kind of split based off what kind of category is of FL. So this is one category of FL, this is a second, etc. Or you could do year and split it up another way. And just kind of like before with BASAR, remember with the par, with the MF row argument, if you do, the first thing here is going to be the number of rows or split up by rows. And the second one is going to be the columns. It's a little confusing because it's using tilde, which is kind of like the formula. But if you put it to the right of tilde, it'll create new columns. If you put it to the left of the tilde, they'll create different columns, or sorry, different rows. But you can also do both and create squares out of all of it. Or you can do wrap, which allows you to do one of them, but it just kind of puts them side by side and wraps around to the other side. And then you can also set if you want to have the scales like the X and Y be the same or what's considered free. So if it's free, it means that like if with one of those panels of your facets, it has say like only half the categories, then if it's free, it's going to remove those ones that are empty. But if you put free Y, it would actually keep all those X ones, but the Y axis would change. And then finally, just kind of I mentioned before with scales, scales allow you kind of to fine tune some of the stuff. So you can change the default colors you give, you can change like the breaks or the labels. It allows you a lot of opportunities. And depending on what kind of variable it is, so how all of it works is that it says scale underscore, and then you name the geom you're kind of using for that, or sorry, the aesthetic you're using. So color, fill, line type, shape, size, etc. Alpha is like opacity. And so if it's in a continuous thing, like say alpha or size, you can plug that in. If it's say like more discrete, say like line type or shape, it would work for that. Scale manual allows you to choose exactly which ones you want, but this is just a way to fine tune it. And then finally, as I was mentioning before, the normal ggplot isn't too great, it has this kind of ugly gray background, but you can just easily tack on these themes and it'll make any of these different kind of themes you want. I think the theme underscore BW, so it's probably the cleanest of them, but I think any of them look great. And you can pull a bunch of other themes, especially from like other journal publications, and get kind of their styles as well for fun. So let's go back to R and go through some of these examples. Pull out of that. So getting back into ggplot. So I loaded ggplot already when I did the tidyverse. And so now let's go through and create some. So as I mentioned before, we can pipe in the data here. So toy is our data set we're using. I'll just show you toy again in case you forgot what it is. So A and B, these are both continuous variables because they're numbers. And so it'll create a scatter plot when we add GM point. But first, just to show you just like the idea of just setting the foundation. So we're plugging into the object ggplot, which will create our data. And then so the mapping we'll use is using the AES for aesthetics. So this is setting up the X and Y for all of our, everything we'll do down the line. So X will be A from this toy data set and Y will be B. And so when you run this, it's actually just going to create that base plot. So this is kind of setting up everything you're going to plot everything on. So this is, so if, yeah, everything will fit within this field right here. So then if you just want to add the points, you tag on with a plus sign and then GM point, and that'll create the points in the data set. You can see here they are added right on top. And it's say instead of points you wanted a line, you could just do this and attach all the points to create that line. And you can also do both by putting lines and then do points. And you can see both of them in there. And since like we didn't put so one interesting thing we can show you is like, say we put color in here. So color equals, let's say, blue. If you set color equals blue, oh, actually, I messed this up because this might be bad. Sometimes color works better outside. No, never mind. This. One of the tricky things you can never remember if stuff goes within it or not. Oh, I forgot how to change that. Never mind. Skip that. But I could change color equals blue here too. This will change the line color to blue. And I can also change the color of this to like another color, red. And so you're going to modify those pretty quickly too. I believe it didn't work for this aesthetics because I need to set a variable, but don't worry too much about that. Okay, actually, I'm setting this to blue anyways here. And so we can just kind of do like we did before. So to make the title, use ggtitle. To change the X label, it's xlab. And then there's ylab for the Y label, xlim, very similar. And then we'll also add the theme bwzc. We'll get rid of the ugly gray background and make it prettier. So there's the title, there's the labels, and now it's zoomed out the same way. So then we can add the red line as well. Since the red line is coming from a different data set, we can plug in the data into the GM line, a second GM line here, and then that will actually create the red line as well. And then here's all of our stuff to clean it up. So we can run all of it together. It'll look like the clean plot, but now with the red line. So you can add other data in there. The other thing you can do too is, as opposed to just adding that data like this, if you wanted to be more technical, you could also just say create two different, or merge them into one data set or one data frame and name like one data set 1 and data set 2. So I'm just going to create, say, a redline ggplot. And so this is that redline data frame. I'm going to have a new column named dataset, when we'll call them all dataset 2 for the redline. And then the toy one will name all dataset 1 by mutate. And then you use this function called bind rows. And what bind rows does is it just kind of takes one of your data frames and your second one and just kind of pastes them together, appends it at the end of it. And that's kind of great because we're not actually merging, right? We're just kind of pasting them together because they all share the same rows, or sorry, same column names. So work really well. And so you'll see that now we have like both of them in the same data frame. So here's all the red line data below. Here's the toy data set above. And so when you do this, now we can add call equals data set, and we can add that variable in. And then now it's going to change the colors of them. Oops. Cool. And it creates it. And then, as I was saying before, with scale, then you can actually change the kind of some of the aesthetics within it. So right, we had our call one here. We changed the color here to values where the first factor is blue and the second is red. So the blue one now is data set 1, the toy data set, and red is the red line data set or data set 2. So that's kind of more of what I would say to do for plotting two lines within ggplot, because most of the stuff you're working on will be in, say, some kind of data frame to begin with. But either way, it totally works. Now to add regressions on top of all of this. So you can actually add a GM called smooth and actually plot. It will actually find the best fit line and plot it. So we'll use method LM here. It'll also give you some kind of confidence interval as well. If you set SE equals true. So that's where you see that kind of gray bar around it. That's the confidence interval. So if you might see figures like this in publications, it's very common to see plots like this. You can also use GM abline and actually plug in the coefficients. It's a little complicated here because you're extracting the coefficients from the model we ran way earlier, but it can be done. And so slope is the second value here. And we're using the double bracket to pull out the value because it's a list. And so it looks complicated, but it can also be done. I guess I don't. The other way people will also plot lines is say they'll create a whole other data frame, and then they'll have some kind of form, they'll have some kind of model they ran, say like a linear model, but maybe there's like a quadratic term. And then what they'll do is like create this vector of like a bunch of values of X. And then what they'll do is then plug in those X values into their best fit equation and kind of compute the predicted values. And so typically people just plot those predicted values onto their plots and then draw a line using the line, GM line. But either way works. If you have more complicated stuff, you're usually going to do that prediction kind of form. Okay, so now I'll kind of show you facets. So one thing we can do is we can use the data sets as different facets. And so this is kind of like the same thing we had before. Here's it in points. I just changed it to points, but it could be lines. But then we'll add this function called facet underscore grid. And then we'll do data set, tilde, and then dot. And dot just means it just assumes, it allows it just to assume anything after that. Don't worry too much about the syntax here. But since I put the data set first, right, it's going to create two rows, one for data set 1 and one for data set 2. You can see that pretty quickly. Data set 1, data set 2. So you see it's separated. And then below here, it's all the stuff just to make it prettier. So it doesn't change any of the underlying data. You can also go down here and then say we can flip it the other way and do tilde data set. If you do it this way, it'll change it now to be in different columns. And if we had another factor, you could plug that in and create like a whole grid too, a facet grid. Awesome. So box plots, we'll go back to the long form because ggplot works all in long form data. That's how it works because it's in the tidyverse. That's what they are huge fans of. So if you use the box plot long one, we can just plug it in here. Our X is our groups and our Y is our vowels. Now we're using gm underscore box plot to create it. And then theme, and that creates that box plot. What if we want to save figures as ggplot? You can use the same export method as we did earlier, but you can also do it quickly using these functions called ggsave. And so actually, oh, I'm just jumping ahead. Let's actually do putting two figures on one. So with ggplot, you can also, instead of just running it and creating the plot, you can also save it to an object. So if I take that first one where we're using the toy data sets with the faceting, you can actually save this to fig1. And so if you run fig1, it'll just pull up this data set. Same thing we'll do for the box plot, name it fig2. So say we want to plot both of these on the same page. There's a lot of ways to do this, and a lot of people have come up with packages. I personally prefer cowplot. I think it's really easy to make figures. So let's just use cowplot. So you might have to download it, and as I said before, you can just go to install. Cowplot exists and hit install for that. But it looks great. I think it's really useful. So you use this function called plot grid, and then you list like list the objects or figures you want to include. So fig1 and fig2. You can throw in labels, and it'll actually then label each of those and the size of them. So if you do this, you'll put them side by side. And so now you have both of those in there. And if you read any of the documentation on cowplot, you can do much, much more complicated stuff. Change actually the size in each of the two, order, and all that. But I won't go into that because there's really good tutorials and stuff online for that. But say we just want to save that fig1 to file, not even going to bother with the plot grid. We can just say plot equals fig1, and then the file name of ggplot to file. So this is the file path for it. And so ggsave will then save that to file. And then you can also, if you're doing a big pipeline, to ggsave. Also pipe in your plot into it as well. So you can connect it, I believe. Though I'm not totally certain. That's a while. Let's see. I think it should work. Yeah, it works. So you can also pipe it in that way as well. So at the end of all your ggplot, then you can use the pipe and then pipe it in as well. Cool. So that's kind of my overview of base R and ggplot. Now I just want to show you some examples using some data from the New Mexico Water Data Initiative and just showing you kind of how some of these things could work. One thing I'm just going to mention, I'm going to use the package lubridate to clean up the dates in there. So as I was saying before, like to do any kind of plots, first you need to clean and tidy up the data. So I'm going to do that first. And I'll kind of run through this quickly because it's not really the focus of this tutorial. But first, I downloaded this data set from the website. So this is just different water levels of wells across different counties in New Mexico. And I put it in this folder called data. And just if you look at the sheet, you'll notice that all the NAs are labeled null. And so I'm just going to switch them using this NA equals null argument to make it much easier to work with in R. And then read underscore CV will read in this thing. So we'll get this object called water table. And so here's the data reading in. See, NAs are now everywhere, which is great. Makes life so much easier. And so with this data set, the most important columns I'm going to be pulling out are mostly this point ID, which is this name for an individual well, the county it's located in, and completion. I think it, well, what's the other one to pull out? So much code. Okay, here it is. Did I go too far? Yeah. So I'm going to pull out county, depth source. So I think this is who measured it. And then depth to water, that's going to be our main response variable you'll work with, and date measured. So this will be the date they went out and recorded the depth to water for each of these wells. And so first thing I'm going to do is convert date measured from characters into an actual date. And we'll do this using this MDY function from lubridate. And if you're not too familiar, it's just basically you say what kind of form the data is in to begin with. So if we look at this, we see that the dates are labeled from month, day, year. So we're just going to specify that by month, day, year function. And so I'm rewriting this over using mutate. So now it's in the correct form. And then I'm going to actually pull out the year from each of these dates by using the year function from lubridate. And then so we'll end up with now another column. Oh no, I forgot. Did I create something? Or do I have to debug live? Be exciting. Oh, did I run lubridate? Let me make sure. So let's make sure the date reads in properly. Okay, yeah, it looks like the date changed. And so first thing you can just tell, things look good. This is a character for point, county's character good, depth source character good, depth of water's ring is a double, perfect, we need numeric, and then date is date measured as a date. Because if we look at original one, you'll see that it reads in, no, it doesn't show it yet. I think completion date, right? You can see, so this isn't date measured, but it's another date. I can't get, but you can see with this date, it's reading as a character, which is not super helpful. So the date functions are working as it should. And then we're going to get rid of NAs within the columns depth source, depth to water, county, just make it easier to work with down the line. So it's our kind of clean data set. And one thing I noticed when I was playing with this, and I'll show you it, is that you always want to just make sure nothing weird's going on with the data. And I notice if you see that Taos is spelled all caps here, but then not in all caps elsewhere. And just to clean that up, I use this thing from string R, which is a way to clean up strings from tidyverse. And so I just took all the counties and I use this function called str to title. So it makes it in title form. So the first layer is always capitalized. Oops. Oh, I copied the wrong thing. use this here, title. It converts the cases of this vector or this column county. So I just made it to title because that's kind of how you would read counties anyways. So we run all of this, we get a new object called water table clean. Everything looks great in it. I just named it clean because it's like cleaned up the data with it. So now let's just create some plots of actual real data. So first I'll create a box plot showing the different years and some different counties. To make life simpler, I'm just going to pull out some of the years. So I'll filter it down and only some of the counties as well. So I'll just do any years 2014 onward and only one of these counties. So using the in operator, as I mentioned to you in the other video. So it makes it a much smaller data set. You can see we've got like 6,554 rows because there's 10 here. And then they show you the 10 below. But now it drops it down to like 1,000. So it becomes much more useful. And then now we'll create the ggplot for it. So first ggplot, and to create the box plots, right, we want to do it for the different counties. And then y equals the depth to water. And just to make sure it's computing the right box plots, we can actually plug in what kind of one we want it to group by to create the box plot. So I'm going to do by county. So plug in the county there, and then gm box plot to create that. And then I'm going to create individual panels for each of the years. So facet wrap will then put them all side by side. So just to show you kind of first how this would look like before we split up the facets, right? Here's kind of the base we're working with. So here are different counties, and then we'll have different box plots for each of these. And then when we do box plot here, this actually might be really messy because it's gonna, actually it won't be too bad because it'll actually summarize all the years within each of these. So this is over all the years, but we want to separate it out by year. So we're gonna use that facet wrap. So when you facet wrap, you can see 2014 through 2019. And the labels get a little smudged there, but if we zoomed, you can actually pull it out and see it's readable if you made it bigger. So yeah, so here you can see the depth to water for all the different wells they measured in each of these counties over the years. So just like that, we got a pretty cool in-depth figure from just 10 lines of code, or not 10, 5 or 6. 5 lines of code, so not too bad. What if we wanted to create the same exact figure in R? It's really complicated. I'll give you just kind of the overview of what I'm doing. I won't probably explain every step because it's throwing in a bunch of stuff we haven't talked about in this class. But the only way to really do it is to kind of individually compute each of those panels and then use the par mf row one to create all of them, put them all together. So it's basically like take your data set, pull out everything only from 2014, compute it, then do 2015, compute it, etc. So to do that, first I just create this smaller data set to work with, just called box plot water. And then the whole idea is I'm just going to use a for loop setting year to a different value, 2014 through 2019. And it just creates a box plot, same idea. And then I'm using paste here to name each of them the year or the index within this for loop, and then ylim, so everything has the same y scale. So if you run all of this and make sure I've got everything set, it'll create the same plot. Of course, this is actually more like x is free because I didn't specify then make sure they have all the same county. So if counties are missing, they're in one year, they're just not in this individual plot. But in theory, you could create the same plot in the same way. It just requires more coding, knowing how to do for loops, etc. But yeah, so these examples are a little unfair to base R. I mean, most people are usually not doing something like this. They're usually only putting 1 or 2 plots together. But just wanted to show you how you could do it in base R as well. So let's look at, and then so here's a plot of just, so you could look at how the individual wells are doing over time. And so with this one, I'm just plotting data from Taos. And so on the x-axis, right, we have date measured, y-axis is water depth to wells, and then color equals the depth source, so who reported it. And if you have questions about all this on the New Mexico Water Data Initiative, they have another file called the Data Dictionary, and you can actually look up what each of these columns mean and get some more metadata on it. I'd highly recommend that for any of the other products you're looking at. I wanted to create lines for each of the wells and connect them, like in the individual wells. So like it wasn't just a bunch of scatter points and you can't tell which well is which. So I use that group equals point ID because that point ID refers to the well. And so you can see in the figures, there's some points that connect because they've measured that well multiple times, but other ones are only dots because they've only measured it once. So this one I didn't bother creating in base R because I would have to iterate probably over each of those individual wells. It'd be doable, but it's not worth either of our times, anyone's time. So I'm not going to do that. But just to show you kind of the base figure for this before we add the GM line, right? It's just going to show date measured, depth to well. Then we add the GM line, and I'll create all the individual lines for each of these. GM point, and then we'll create it for individual dots for each of them. So it makes it much thicker because then it shows the individual ones. The wells are only measured once. Theme cleans it up, and then I put a title in also. Another thing you'll notice too is that ggplot's much slower than base R in creating figures. So there is some cost when you're doing you have a lot of data, but you just can wait like a minute or two and it'll pop up. How about we count the number of wells that are measured per county and year? So we can do this pretty quickly. Let's pull out the same kind of counties we did before. Do same kind of, or this time we'll skip 2014 data and do 2015 onward. And then so we can just quickly tally this up using this dplyr pipeline, using group by county and year, add them up. If you have questions about this, go back to the tidyverse package or video, and that will help, or the tidyverse package tutorials. And so this creates just a quick data frame where I have county, year, and the number of wells added up that they were measured. And so to plot this, we just take our well count. The X variable is going to be year, and then Y is the number of wells. So you can see here, X, Y. And then we'll add the GM bar. One thing you have to keep in mind for a ggplot is you have to add stat equals identity to create a bar plot. So make sure you keep that in mind or it won't work because we're already counted up. So here it is, just the number of wells counted per year. But of course, we don't care just overall. We want it split up by county. So we add that facet grid. And there you go. It'll give you the well count by county and over time for all the years too. So you can get a lot of cool data. You can see vast majorities in Socorro County. And yeah. So that's kind of, you create that figure. To make it in base R, it's the same kind of idea as before. You're going to do every individual panel as one plot and then paste them all together by using the power function. So I'll just run it through here. We're iterating over county, so I'm going to create a vector of counties that we'll use for the for loop. Don't worry too much about this, but this is just creating a bar plot the same way. And then so you can see, you can create it this way too. And this is what the bar plot would look like in base R. So that's all I have for base R and ggplot. As I said before, please let me know if you have questions. There is so much more you can do in ggplot that I didn't go into. Definitely check out the RStudio cheat sheets as well. They'll give you lots more information on all the stuff you can kind of change and modify and make it exactly the way you want it to be. There's so much more you can do. I mean, you could be creating maps, etc. We'll get into more of that later. But thanks.